of the Building a 2G GSM Network series. Now in this episode, we're going to cover SDR basics, primarily around the network we are going to build, but also what other exciting things you can do with an SDR. It's going to be a very nerdy video, so buckle up. Now, what is an SDR? Well, that stands for Software Defined Radio. And these boards come in all shapes and sizes, each with their own unique capabilities. Basically, an SDR is nothing more than a radio on a circuit board that captures radio frequencies, or RF, and hands them off to software for processing. That same software then tells the SDR what to broadcast back and at what frequency. This is referred to as modulation. The specs of your SDR are very important because some can only listen or broadcast at one time. That's known as a half duplex SDR. Now, in order to create a lab cell network like we're doing here, the SDR needs to be able to listen and broadcast at the exact same time. These are called full duplex SDRs. In addition, the frequency in which the SDR can transmit and receive is also vital. Typically, the cheaper options like the one I have in front of me are limited to the frequencies that the project requires. 2G GSM utilizes the 850 to 900 megahertz range and also the 1800 to 1900 megahertz range depending on your region. Now, the board I have here is a URAN-1 and it can only broadcast and receive on the 850 to 900 megahertz bands, and you'll notice it has two antennas, one to broadcast and one to receive, making it a full duplex SDR. Other more expensive SDRs offer full spectrum capabilities. These can often broadcast and receive on any frequency, opening up an entire world of options that I'll explore more at the end of this video. Now, modern full-size cell towers are nothing more than a room with network switches and fiber that runs to the antennas at the top of the tower. That's it. It's actually really straightforward. Now, this URAN-1 starts at $100 on eBay, and it's basically just a mini lab version of those big towers. The URAN has no actual software on board and acts as the antenna on a tower. The only features it has are a power port and a USB port, and it's completely driven by software over USB 2.0. Now, the only software I can find that officially supports this specific board is OpenBTS, which is Linux-based and an open source software that emulates a real-life cell tower. This is reflected in the incredibly complex configuration files required to make OpenBTS work. This entire process will be featured in the next episode that's installing and configuring OpenBTS. Other SDRs can work for a project like this, like the Lime SDR, which I believe also utilizes OpenBTS, or the very expensive Nuon Blade RF. That is a full spectrum SDR that works with YATE-BTS, which is way more user-friendly with a web interface instead of SQLite databases like OpenBTS uses, and it can even support Edge and 3G, unlike OpenBTS, which is limited to GPRS. That's the evolution before Edge. Now, funnily enough, DasDude1 just happened to upload a video covering that exact SDR. If you want to learn more about it, I added that video to the description. But for those of you that are cheap like me, stick around to see the completion of this project. Now, we already mentioned that the Blade RF can handle 3G, but it can do so much more than that. Some SDRs like the Blade RF can handle 4G LTE or even 5G. Also, going beyond cellular, these SDRs can receive AM/FM radio, TV signals, aircraft tracking, weather satellites, Wi-Fi and Bluetooth, police, fire, EMS radios, amateur radios such as CB, PSK31, FT8, and even radar analysis. Now, of course, this means you can also broadcast on all these frequencies, and which I mentioned in my last episode, you need to be really careful with that. And if you're going to experiment with it, do your research. With that, I hope that you enjoyed this nerdy deep dive into the world of SDRs. I tried to make this video as accessible as possible to beginners who are just curious, while also offering specs to the advanced viewers. I hope I found that line and that whatever skill set level you're at, you enjoyed this video. A reminder of what the rest of the series has to offer, episode 3 is next. That's going to be installing and configuring OpenBTS, followed by episode 4, and that's going to be the final project demonstration to show how all the pieces of the puzzle fit together. Make sure you subscribe so you don't miss the rest of the series, and I will see you in the next video.